If f of x equals 4x squared minus x cubed, find the first, second, third, and fourth derivatives of f of x. So we're going to start with the first derivative. We've done this many times now, so hopefully it should be fairly easy, even if there's a lot of algebra we have to do. We've got the limit as h approaches 0 of our function at x plus h. So it's going to be 4 times x plus h squared minus x plus h cubed minus the original function, which is going to be 4x squared minus x cubed all over h. Now there's a lot of calculations we have to do, which is a little bit annoying. I'm actually not going to do them all out because we don't have unlimited space or unlimited time, but I encourage you, if you do not have practice doing all of the algebraic steps, I encourage you to do the algebraic steps here. So for 4 times x plus h squared, we know x plus h squared is x squared plus 2xh plus h squared. Multiplying all that by 4, we're going to have 4x squared plus 8xh plus 4h squared. And then we've got to subtract x plus h cubed. This is a calculation I've done at least once already for this class. I'm not going to write it all out again. It's going to be x cubed, and all of these are going to be minus because we're subtracting this, minus 3x squared h minus 3xh squared minus h cubed. Whoop. And then we are distributing the subtraction to each of those terms, so it's going to be minus 4x squared, and then plus x cubed all over h. Now let's hope that we've got a few things canceling out. I see a positive 4x squared and a negative 4x squared that cancel out. I see a negative x cubed and a positive x cubed that cancels out. I think that's all that's going to cancel out, but each of the remaining terms is divisible by h. So let's go ahead and do all of those divisions so we can simplify things. So we have the limit as h approaches 0 of 8xh divided by h is 8x. 4h squared divided by h is 4h. Negative 3x squared h divided by h is negative 3x squared. And then negative 3xh squared divided by h is negative 3xh. And then h cubed divided by h is h squared. Now we're looking at the limit as h approaches 0, so all of the terms that have h in them are going to become 0. And this is going to leave us with 8x minus 3x squared. So this is the first derivative of f of x. Now, if we want the second derivative, we need to differentiate this. So f double prime, f biz of x is going to be, again, we need the limit definition, and we're going to plug in x plus h to this function, because we're taking the derivative of the derivative. So this is going to be 8 times x plus h minus 3 times x plus h squared. That's our function, f prime of x plus h, and then minus f prime of x, which is going to be 8x minus 3x squared all over h. All right, let's do this on the next line. We end up, when we expand things out, getting 8x plus 8h minus 3x squared minus 6xh minus h squared, and then minus 8x plus 3x squared, because we're distributing that negative, and subtracting a negative gives us a positive. Now let's see what cancels. Let's play our favorite game. Negative 3x squared and positive 3x squared, positive 8x and negative 8x. Those cancel. Everything else is divisible by h, so let's go through and divide those things by h. We've got the limit as h approaches 0 of 8h divided by h is just 8. And then minus 6xh divided by h is 6x. And then minus h squared divided by h is h. And if we take the limit of this as h approaches 0, it's the last term that disappears, and we're left with 8 minus 6x. That is the second derivative, and we need to differentiate that to get the third derivative. So, for the third derivative, again, it's like deja vu. We need another limit as h approaches 0. But the thing that we're going to plug in, x plus h to, is our second derivative, which we're differentiating to get the third. So it's going to be 8 minus 6 times x plus h minus the function at x, 8 minus 6x, all over h. All right. If we multiply things out, that's going to be 8 minus 6x minus 6h minus 8 plus 6x all over h. We play the cancellation game. The 8's cancel and the 6x's cancel. So we're left with negative 6h over h. The h's cancel, and we've got the limit of negative 6 as h approaches 0, which is just going to end up being negative 6. So the third derivative is a constant, and we have already seen that the derivative of a constant function is 0. That's because a constant function is a horizontal line. The slope is always 0, so the derivative is going to be 0. So we don't even, I think at this point, need to do the calculation, though you can if you want, but we're going to end up getting 0 for the fourth derivative and any subsequent derivatives.